So in our Year 11 calculus, we got pretty good at differentiating polynomials, but we generally only looked at positive indices. So in this video, I'm just going to give you a quick run through on how you do your differentiation of polynomials when you have negative indices. Okay, so the reassuring thing is that it's actually exactly the same as when the indices are positive. So remember we had this generalization which said if we've got x to the power of n, then to differentiate, to get f prime x, you just bring the power down in front, multiply it by a coefficient if there is one, and reduce the power by 1, where n is obviously a non-zero integer. And the same thing applies for constants, where if you have a constant, then the derivative of that is just 0. Okay, so exactly the same thing applies. Now, just to prove it to you, so that you can rest assured that I'm telling you the truth, I will show you how to do this example by first principles. So this is where we use our small distance between the 2 points of h, so that distance there is h, and then we use the limit as h tends towards 0, because obviously as this chord, or this secant, these points get closer, then the gradient of the secant is a better approximation of the gradient at that point. Okay, so I'll show you how to do this by first principles. You're not likely to need to do this a great deal, but it's certainly good to be able to understand it and to be able to work through the algebra, sort of a little bit of algebraic gymnastics for you. Okay, so we've got f of x equals x to the power of negative 3. The one thing we do have to just be aware of that obviously x cannot be 0, because this is 1 over x to the power of 3, and if x is 0, that's going to be a problem. We'll talk about that in a little while. Okay, so the derivative from first principles, f prime x is, remember, f of x plus h minus f of x over h. So what I'm doing there is working out the rise over the run. So this is your y value of your second point. This is your y value of your first point. So we're doing rise and then over run, which is just the distance between the x points there. So for this one, I'm doing simple substitution. Instead of x in here, I want x plus h. So it's x plus h to the power of negative 3 minus x to the power of negative 3 over h. Okay, and this is where the algebra comes into it a little bit. Okay, so we can rewrite this by saying, well, let's get rid of this for a minute. We'll just put that over here as times 1 on h. Okay, and this bit is 1 over x plus h to the power of 3 minus 1 over x to the power of 3. Okay, so all I've done is write these two with positive indices and just taken this over h out here because I want to deal with this bit and not worry too much about this bit at the moment. Okay, so in order to add these together, I need obviously a common denominator. So what I'm going to do is multiply this up. So x cubed, multiply this up, x plus h cubed, and that will all be over x cubed times x plus h cubed. Now I'm going to need to go on to the next page in order to do that, but the next thing we want to do is expand this out and then see if we can do some cancelling and simplifying of the top line. Okay, so just moving on to the next page. And so we have got f prime x. So just expanding out, we had our x cubed, and then if we expand out the bracket, that gives us x cubed plus 3x squared h plus 3x h squared plus h cubed. Remember, you can use Pascal's triangle in order to do that nice and easily. Okay, and that's going to be over x cubed times x plus h cubed, and then of course still times 1 over h. Okay, now when I simplify this, that will cancel out with that, and this will leave me with what's left in here. Don't forget that it's negative out the front, so negative 3x squared h take 3xh squared take h cubed over x cubed times x plus h cubed times 1 on h. So I can cancel the h's on the top here with the h on the bottom there, so that gets rid of that one, gets rid of one of those, gets rid of one of those. Okay, and now what I'm going to do is my limit. So I want to limit as h tends to 0. Okay, and when that happens, that makes this 0, it makes this 0, and it also makes this part 0, so that just becomes x cubed there. Okay, so what I've got is negative 3x squared over x to the power of 6. Okay, when I cancel that with that, I get negative 3 over x to the power of 4, or negative 3 x to the power of negative 4. Okay, so remembering we started with f of x is x to the power of negative 3, and we can see that f prime of x is negative 3 x to the power of negative 4, so we've just done the same thing. Taking the negative 3, brought it down, negative 3 out the front, times x, and reduce this by 1. Okay, so obviously if you take 1 off there, you go from negative 3 to negative 4. Okay, and you can write it either way, unless the question specifically says write it with a positive power. Okay, so just to note that you do need to consider the restriction that x cannot be 0, because we know what happens when you divide by 0. Some kind of otherworldly implosion. Okay, so you'll find in most of the questions, particularly in the Cambridge textbook, they're very specific about defining that x cannot be 0, as you're seeing here. So for all the real numbers except for 0. So just be aware of that one. Okay, so let's do a couple of simple examples. We want to find the derivative of this. Okay, so y prime is going to be, well, the first one's just 4x cubed. Let's put that positive. Okay, now we want to do this part, so bring down the negative 3 times 2x, reduce it by 1 to negative 4. Okay, plus, bring down the negative 1 times x, reduce the power by 1 to negative 2. And that's a constant, so that's basically plus 0. And here we have our restriction there on the domain. Alright, so if we're going to simplify that a little bit, 4x cubed, that's going to be plus 6x to the negative 4, take x to the power of negative 2. Okay, and again, you can write that with positive indices if you want, and just for x is not equal to 0. Okay, so really straightforward, no different at all, really, from doing it with positive powers. Alright, slightly different form of a question here, so find the gradient of the tangent. Okay, determined by this function at the point 1, 2, so that means where x equals 1. Okay, so it's just asking for the same thing. Find the derivative and then substitute in the value of x equals 1. Okay, so differentiating first, we've got 2x, and of course this can be rewritten as x squared plus x to the minus 1. Okay, so we've got our derivative that there is 2x plus minus 1 times x to the minus 2. Okay, so we've got 2x take 1 over x squared, and now we want to find out what is the value of that when x equals 1, so substituting in 1 there, 2 times 1, take 1 over 1 squared, okay, gives you 1. So the gradient of the tangent to the curve at this point is 1. And then you could go on, use that point, and find the equation of that tangent if you needed to. Okay, this last question is slightly more interesting. Shows that the derivative of the function is always negative. Okay, so when you get a question like this, you might look at it and think, well, okay, I'm not really sure how that's going to work. But you do know that you need to differentiate it because it says you've got to show something about the derivative. So just start with that, and you'll often find that the solution sort of makes itself fairly obvious once you're about halfway through. Okay, so let's differentiate first. F prime x minus 3 x to the minus 4, or minus 3 over x to the power of 4. Okay, and it says we want to show that this is always negative. So what you need to look at is this x to the power of 4 here, because this is our variable, so where we're putting numbers in. If you put an a positive number in there, obviously you will get a positive number, but if you put a negative number in there, you will also get a negative number, because when you have an even index, you'll always get a positive number. When we're talking about real numbers, okay, we'll always do a positive number. So if this is always positive, then this is negative, so you'll have a negative divided by a positive. So you'll have negative divided by positive, and therefore the answer will always be negative. Be negative. Okay, so you can say that f prime x is minus 3 over x to the power of 4. We know that this will always be positive, therefore the value of f prime x will always be negative. So that's it for differentiating polynomials with negative indices. As you can see, it's the same as positive indices. Bring the power down and reduce by 1. You may find that a number line helps at the beginning. Now, I know this seems a little bit sort of year 7, but when you're sort of doing all this stuff for the first time, or maybe the second time, it can be a little bit confusing. So if you're doing something and like, oh gosh, I had a -3, where am I going? Which way am I going? Okay, you know that you started at -3, you're reducing by 1, going to -4. I don't expect that you'll need it very much. Most of you probably won't need it at all, but it's better to just do a quick sketch of something like that on an exam or a test and get the mark, rather than sort of just wing it and not get the mark. So even if you don't write it down, you can always keep that in your head. Do remember, though, that you can't divide by 0. So you need to specify x cannot be 0 if you've got anything with 1 over x.